Good morning. Today we're going to explain about the first chapter of dynamics. My group consists of myself, Nicholas, Kogulan, NITHYA, THENNARASAN, and MEERA. I will explain about continuous motion and erratic motion. What is dynamics? Dynamics is a combination of static and dynamics, which we can divide into kinematics and kinetics. First, continuous motion. Position is the location of an object, and displacement is the change in position. Velocity is the rate change of object displacement respect to time. There are several important formulas which are average velocity, instantaneous velocity, speed, and average speed. Acceleration is the rate which an object velocity changes respect to time. We can get acceleration by differentiating velocity once and position twice. As we can see here is the summary of displacement, velocity, and acceleration. To put it in a nutshell, we can get velocity by differentiating position once, and we can get acceleration by differentiating velocity and integrating them to get the otherwise. To calculate constant acceleration, these are three important formulas. Exercise: if a particle has initial velocity of 12 per second, position equal to 0, determine its position when t equal to 10 seconds if acceleration 2 feet to the left, which means left is the opposite direction of our velocity, so acceleration will be negative. So by using the acceleration, we will integrate once to get the velocity equation and integrate one more time to get the position equation. By using the position equation, we will substitute our value and we will get position equal to 10 seconds is equal to 12 feet. Now let's have a look at erratic motion. First is a position time graph. Second, we have velocity time graph. And finally, we have acceleration time graph. So we are given ST graph and we are asked to draw VT and acceleration time graph. We will divide the graph into two, which is 0 to 5 seconds and 5 seconds to 10 seconds. So by using the equation given 0 to 5 seconds, we will differentiate once to get the velocity and differentiate twice to get the acceleration. Same goes to 5 to 10 seconds. So first to draw velocity time graph, we will take the equation which is 6t and we will substitute 5 seconds and we will get 30, which is the velocity. So we will draw a line, and for 5 to 10 seconds the velocity is 30, so the line will be a horizontal line. Same goes to acceleration. So acceleration for 0 to 5 seconds is 6, so we will draw a line here, and the acceleration for 5 to 10 seconds is 0. So this will be the line and we will connect it. So we will get acceleration time graph and velocity time graph.
Let me explain about curvilinear motion. Curvilinear motion have two types, which is general component and rectangular component. So first of all, I want to discuss about general components, which is position, velocity, and acceleration. Before that, I want to explain about what is curvilinear motion. Curvilinear motion is when a body moves along a curve said to be in curvilinear motion. So next, general curvilinear motion in position and displacement. So a particle moves along a curve defined by the path function. So the S we can refer in figure. So next is general curvilinear motion in velocity. Velocity replaces the rate of change in position of the particle. So next, acceleration. Acceleration replaces the rate of change in velocity of a particle. So we move to the next type of curvilinear motion, which is rectangular component. In rectangular component also we have position, velocity, and acceleration. So what is curvilinear motion in rectangular component? So rectangular Cartesian coordinate axis x, y, z are related with the unit vector ijk. So in position, the position of particle can be defined in any instant by the position vector, which is vector r equal to xi plus yj plus zk. So in velocity, we can see in this slide vx equal to x dot, which is one time differentiation of position. So we can get the vx. So in acceleration, we can see that x above that in 2 dot. So 2 dot means 2 times differentiate the position. So we can get the acceleration. So now I want to explain about one of the example in curvilinear motion. So this is a question. Now I want to explain the solution. So differentiate the y equal to 2.5 x square to find y dot which is velocity of y. So after we identify the velocity, we need to find the magnitude with the formula. So after that, differentiate the equation 1 to find y double dot which is acceleration of y. So after that, we need to find the magnitude of acceleration.
Hello everyone, thank you so much for being here today. I am THENNARASAN Rajandaran. Today we are going to refer the motion of a projectile covered under the chapter of kinematics of particles. Well, introduction. The motion of a projectile refers to the trajectory followed by an object projected into the air and subject only to the force of gravity and air resistance. This type of motion is characterized by a curved path, typically in the shape of a parabola, and is a classical example is physics. Well, as you guys see, this is the application of projectile motion. This is an example video that you guys can refer it by click the play icon. I have attached the link. This video explains about common example of projectile motion is a ball thrown up into the air. The ball will initially travel upwards until it reaches its peak height and then it will fall back down to the ground. They are the two components of the projectile's motion, which are horizontal and vertical motion. Horizontal motion, known as x-axis. Since ax equal to 0, the velocity in the horizontal direction remains constant and the position in the x direction can be determined by this equation, which is x equal to x naught plus v naught xt. Well, vertical motion, known as y-axis. Since the positive y-axis is directed upward, the ay equals to negative gravity. Applying the equations, we get three of the equations below. Well, let's have a look at the problem number 1. An example of a projectile motion is shown in the figure, which shows a car rolling off a cliff. Suppose the car leaves the cliff with a velocity of 10 meters per second directed along the horizontal. If the cliff has a height h equal to 20 meters, where and when will the car land? As you guys can see, this is the solution of problem number 1. Firstly, write the constant velocity equation for the horizontal direction. Vx equal to dx dt equals v cos 15 degree, where v represent the total velocity at the 15 degree angle. Solving for v equals to dx over dt cos 15 degree. Now write the constant acceleration equation for the vertical direction. Dy equals to 1 over 2 a dt square plus vy dt. Also, Vy will be sine 15 degree. Substituting for Vy, dy equals to 1 over 2a dt square plus v sine 15 dt. It will be equation 2. Well, now combine the equation number 1 and 2 by substituting the value of v. Dy equals to 1 over 2a dt square plus dx over dt cos 15 degree sine 15 degree dt, and simplify it and then solve the value of dt by referring to the questions and figure. The value of dy will be 0 while the value of dx will be 10 meter. So the two equations should be power of 1 over 2. So the answer for dt will be 0.73 second. So now insert the time into equation 1 to find the value of v. So the v equals to 10 meter over 0.73 second multiplied with cos 15 degree. So the answer for v is 14.18 meter per second. So it will be the minimum speed needed for success.
Alright, again I am here to explain you all about the absolute dependent motion analysis of two particles. So these pictures are some of example of this subtopic. So example of application, the cable and pulley system shown here can be used to modify the speed of block B relative to the speed of motor. So it is important to relate the various motion in order to determine the power requirements for the motor and the tension in the cable. So here we have some example of procedure to solve the absolute dependent motion analysis of two particle questions. So if we follow this procedure, we will definitely get correct answer. So let me see the one of the example. Alright, let me explain about this solution. So given cable A equal to 2 meter per second, in this pulley system SA, SB, SC are the position coordinate. In this case, we can see the two cables connected. That means we will end up with two equations. So first equation, which is for first cable, SA plus 2SC equal to length 1, and second cable is SB plus in bracket SB minus SC equal to second length, which is L2. So from from equation 2, we will find the SC to substitute in the equation 1. So after that, we will end up the equation SA plus 4SB equal to length 1 plus 2 length 2. So we will differentiate this one time to get the velocity. So if we differentiate SA, we will get VA. So 4SB, 4VB. So this is constant, so we get 0. So from this equation, we can find the VB. Thank you.
The normal and tangential components. The anti-coordinate system used when the particle follows a curved path. The N is normal and the T is referred to the tangential. The T-axis is tangent to the curved path and the unit vector is UT. The N-axis is perpendicular to the T-axis and the unit vector is UN. The center of curvature always lies on the concave side. The radius of curvature, perpendicular distance between the curve and the center of the curvature. The velocity in the anti-coordinate system, V equal to VUT, where the V is equal ds over dt. The velocity vector is always tangent to the path of motion. For the acceleration, A equal to AT UT plus AN UN. To calculate the tangential component, AT ds equal V dV. To calculate the normal component, the formula is AN equal V square P. To calculate the magnitude of the acceleration, A equal to square root AN square plus AT square. Let's see an example. In this question, they ask to determine the speed and the magnitude of its acceleration when it has moved 10 meters. From the question, they already given the A equal to 0.05 as the starting point is 0 meter and its travel 10 meter. The velocity is 4 and the V is equal to 50 meter. First, we have to find the velocity, get the acceleration. So for find the velocity, we have to integrate. So after we integrate, we get the answer V equal to 4.58 meter per seconds. By using the normal acceleration formula, we substitute the velocity to the formula and get the AN equal to 0.419 meter per second square. From the question, they already given 0.05 s equal to A. So we substitute the s 10 meter to the A and we can get the AT 0.5 meter per second square. By using the magnitude formula, we can square root AT square plus AN square. We get the final answer A equal to 0.652 meter per second square. Let's see about the cylindrical components. We may express the P position in polar coordinates as R equal to R UR. After using the chain rule, finally the velocity has two components, which is radial component R dot, transverse component R theta dot. To find the V, square root in bracket R theta dot square plus R dot square. Acceleration of polar coordinates. The radial acceleration AR equal to R double dot minus R theta dot square. Transverse acceleration A theta equal to R theta double dot plus 2R dot theta dot. Magnitude of A is square root in bracket R double dot minus R theta dot square plus in bracket R. Let's see an example. In this question, they asked to determine the angular velocity of the camera tracking the car when 15 degrees. From the question, they given velocity equal to 40 and the R equal to 100 cos 20 meter and 15 theta is 15 degree. From the from velocity formula, we know that we want to use the r dot. So after we find the r and the r dot, we have to substitute with the theta 15. And after we getting the r and r dot answer, we substitute into the formula v equal to square root r dot square plus r theta dot square. So we know the v is equal to 40. So after we do the calculation, we get the final answer theta dot equal to 0.3 rad over s.
Hi, my name is MEERA Ramakrishnan. My metric number is P0122101002. I'm going to present about the relative motion analysis. Relative motion analysis is a concept of integral to understanding the dynamic of object in motion. It involves studying how objects move concerning each other, providing insights into their motion patterns. This concept finds broad application in physics and engineering, playing a key role in problem solving and analysis. Understanding the relative motion is not merely theoretical, it's a crucial tool for addressing practical challenges in the real world. Translating axes is a powerful method employed in the analysis of the motion of two particles. It involves specifying the location of particles using translating coordinates x prime, y prime, and z prime. Methods for solving the unknowns in translating axes includes visual representation, trigonometric principles, and breaking motion into Cartesian components. Okay, the next slide shows some of the applications. Okay, like cars moving in a different direction, people walking on a moving train, boat moving against the current, and airplane flying in a crosswind. Okay. In an initial reference frame, a particle's position is determined by its location in a fixed coordinate system, while its relative position is determined by the vector from the second particle to the first. In translating axis scenarios, position is measured relative to the moving frame, so it's RB equals to RA plus RB over A. Okay, the velocity of a particle is in an initial reference frame is its rate of change over time, while the difference between two particles' relative velocities is their difference. As shown in the slide, Vb equals to Va plus Vb over A. The time derivative of velocity is d equals to dr over dt. It depends on the position. Okay, the acceleration of a particle in an initial reference frame is its rate of change in absolute velocity over time, while its acceleration relative to another is the difference between their acceleration. So the formula of acceleration is AB equals to AA plus AB over A. The time derivative of acceleration is A equals to dV over dt. The following slides show some of the procedure for the analysis. First one is specifying the location and translating axes, which is x prime, y prime, and z prime. Second one is recognizing the vector addition to form a triangle at most two unknowns. So the third one is solving the unknowns such as velocities or acceleration. Okay, here is an example question based on the diagram shows car A is traveling with a constant speed of 60 km per hour due north, while car B is traveling with a constant speed of 80 km per hour due east. Determine the velocity of car B relative to car A. Okay, here's the solution. In this scenario, we have two cars, car A moving north at 6 km per hour and car B moving east at 80 km per hour. The goal is to determine the velocity of car B relative to car A. This is achieved through vector addition, where the magnitude of the relative velocity VBA is calculated using the Pythagoras theorem, resulting in 100 km per hour. The direction of this relative velocity is determined by finding the angle between the velocities of car A and car B, employing the trigonometry. The angle is approximately 36.87 degrees south of east. Okay, okay, that's all from us. Thank you for watching.